students, welcome you all to the video lecture on signals and system. Today we are going to find out Laplace transform of cos at u of t. Okay. So what is the Laplace transform formula? Laplace of x of t is given by x of s, which is nothing but minus infinite to infinite x of t e power minus st dt. Right. So here in this problem they have given x of t as cos at u of t, right. So let us consider that x of t is cos at u of t, and u of t is unit step signal. Unit step signal means u of t value is 1 for t greater than or equal to 0. Okay, so using that, what I can write x of t as cos at into 1, which exists only for t greater than or equal to 0. Okay, so x of t value will exist only for t greater than or equal to 0, that is positive values of t. Okay, so using that concept I can find out x of s as, so minus infinite to infinite, now it becomes only 0 to infinite. Why? Because of this u of t. Okay, what is x of t? X of t is cos at into 1. Anyway, cos at into 1 is nothing but cos at e power minus st dt. Okay, so when we try to apply here the udv formula, right, so it will be going on. Why? Because one term, that is if we consider u as cos at, right, if we find out u dash, it will become sine, right, again u double dash, again sine will become cos, like that it will be going on. The same term again and again it repeats, it no way it becomes 0. Okay, so we cannot apply udv formula here. So instead let us try to write cos at in terms of exponential term. Okay, so what is cos theta formula in terms of exponential term? It is e power j theta plus e power minus j theta by 2. Okay, so using this I can rewrite this expression as 0 to infinity. I am not integrating, first I am substituting cos at value. So here instead of theta I have at, right, so I can write it as e power j at plus e power minus j at divided by 2 into e power minus st dt. So here 1 by 2 is constant, take that outside, and again I can simplify, right, that is I can multiply these two terms and I can separate the integration. So let us multiply these two terms. So e power j at into e power minus st dt. Okay, that is we are splitting these terms, and plus, right, again this integration is applicable for this term also. So 0 to infinity e power minus j at e power minus st dt. Okay, so I can rewrite the above expression as this. So while seeing this integration, right, while seeing this integration, I have limits 0 to infinite. Okay, so when I substitute infinite, this integration should not become infinite, meaning that I should have e power minus t term as it is. Okay, so that when I substitute t tends to infinity, what happens? E power minus infinity will become 0. Suppose if I have e power t term, okay, when I substitute infinite, it becomes e power infinity, it becomes infinite, right? I should not get infinite term, I should always get 0. Okay, suppose if I substitute infinite, I should get 0 term, I should not get infinite term. So always whenever in the limit, if I have infinite, we should rearrange the term such that we should have minus t term outside. Okay, that is what I am trying to say is here 1 by 2. Okay, so let me simplify first before applying the limits. Okay, integration. Here take minus t outside. Okay, e power minus t outside, so that this term will become s, this term will become minus ja. Okay, So this term and this term both are same. Why? Because minus into plus will become minus e power minus st. It is there. Minus into minus will become plus e power jat. Okay, so this term I can write like this. Similarly, 0 to infinity, take e power minus t outside. Okay, so instead of taking t outside, I should take minus t outside. Okay, only then if I substitute infinite, it becomes 0. Okay, so whenever in the limits, if I have 0 to infinity, right, you should check such that or rearrange your exponential term such that you will have e power minus t outside. Suppose if in the limit, if I have minus infinite, then you should take e power t. Okay, so you should take t outside, but here it is infinite, take minus t outside. So you should remember this step. Okay, so here also minus t you are taking. So here it is plus s, here it is plus ja. Right, so e power minus st and e power minus jat and then dt. So like this you rewrite this expression. Okay, after this let us apply the integration formula. Okay, so what is the integration formula? Let me write here itself. Which is equal to 1 by 2. Okay, apply the integration e power minus t s minus ja divided by minus of s minus ja. Apply the limits as 0 to infinity plus here e power minus t s plus ja divided by minus of s plus ja. Okay, again here also limit is 0 to infinity. 1 by 2 is common for both the terms. Okay, now apply the limits. Okay, apply the upper limit. So anyway, infinity into any terms is infinity, so I can just write this term as e power minus infinity divided by minus of s minus ja. Apply the lower limit. While applying the lower limit, you should have one more minus. So minus into minus plus. Again 0 into any value is 0. So e power minus 0 divided by s minus ja. Apply the upper limit. So here you have minus. So it becomes minus e power minus infinity divided by s plus ja. Apply the lower limit, minus into minus will become plus. So e power minus 0 divided by s plus ja. Okay, so now anyway this term becomes 0, this term becomes 0. Okay, why? Because we have e power minus infinity equal to 0. Okay, now we have only this term and this term. Anyway, e power minus 0 or e power 0 both are same, which is equal to 1. Okay, so this term is nothing but 1. Again this term is nothing but 1. Okay, so for both the terms I have commonly 1 by 2 outside. Okay, so 1 by s minus ja plus 1 by s plus ja, these two terms are there. Okay, so 1 by 2 is common. 1 by s minus ja plus 1 by s plus ja, these two terms are available. So 1 by 2. So since these two terms are different, let us take both the terms in the denominator, which is nothing but your LCM, and cross multiply your both the terms, right? So this term you have to multiply here, this term you have to multiply here. Just cross multiply both the terms. So here it will become s plus ja, here it will become s minus ja. So ja and minus ja get cancelled. So here I have s plus s, that is nothing but 2s. So which is nothing but 1 by 2 into 2s divided by denominator I have a minus b, a plus b. So I have a minus b into a plus b which is nothing but a square minus b square. Okay, so it is a square minus j square a square. Okay, so anyway 2 get cancelled, and then I have s divided by, what is j square value? J square is minus 1. Okay, so a square into, already I have one minus, again j square value is minus, into a square, so which is nothing but s by minus into minus will become plus, so it is a square plus a square. So I can simply write Laplace of cos at u of t is s by a square plus a square. Thank you. Thanks for watching.